Dear students, welcome. Today I am going to start double integration. The evaluation of double integration. Today I shall try to solve these 5 problems on double integration. Before going to solve these problems, I should give you Fubini's theorem. The theorem, Fubini's theorem for rectangular region. Fubini's theorem for rectangular region. Fubini's theorem for rectangular region. Suppose let fxy, a function of x and y, be continuous over a rectangle. Be continuous over a rectangle R, where a is less than or equal to x is less than or equal to b, c is less than or equal to y is less. X lies between a and b, and y lies between c and d. Then the double integrate. Double integration over R, over the rectangular region R. fxy, it is continuous over the rectangular region D, can be evaluated by either of the iterated integrals. The double integration, this fxy dA, first y integration first. Suppose x equal to a to b and y equal to c to d. fxy, first integrate fxy with respect to y. While integrating this with respect to y, treat x as constant. Treat all x's occurring in this as constant. Suppose x square y. What is the integration of this? X square, y square by 2. Suppose x, y cube. Thus treat x as constant. While integrating this, thus treat x as constant. And you may write this. Or this integration first integrate fxy with respect to y, treating x as constant, and then put the values of c and d for y. Then you will get a function of x only. Then integrate this function with respect to x under the integration, the limit x is equal to a to b. Or you may integrate y equal to c to d. First integrate x equal to a to b. First integrate this dx and then this. First integrate this and then this. Then y is equal to c to d. Just while integrating this, just treat y as constant here. Here y as constant. Now Fubini's theorem can be applied only when a, b, c, d are constants. If a, b, c, d are constants, then you may first integrate this with respect to y first, then integrate with respect to y, or you may integrate x, integrate with respect to x, then you may integrate with respect to y. The result will be the same. The Fubini's theorem can be applied when a, b, c, d are constants. Fubini's theorem applies only when a, b, c, d are constants. are constants. Then both the values will be the same. fxy should be continuous over the rectangular region, over the rectangular disk. It is continuous. Then now properties. Now I am going to give you some properties of double integration. Properties of double integration. Of double integration. Properties of double integration. What is the properties of the double integration? Assume that all the integrals will exist. Assume that all the integrals exist on a rectangular region R. Assume that all the integrals exist on a rectangular region R. Then, number one, linearity property. Number one, linearity property. Linearity property. For constants A and B, for constants A and B, double integration over R A fxy plus B gxy dA, this is equal to, this constant A can be taken outside the sign of integration. Just like single integration, you may plus B double integration over R, it should be gxy. It should be gxy. This is called linearity property. For constants A and B, rectangular region is R, then you may write like this. Number two, dominance rule. If fxy is greater than or equal to gxy throughout the rectangular region R, throughout the rectangular region R, then throughout the rectangular region R, then double integration over R fxy dA should be greater than or equal to double integration over R gxy dA. Gxy dA. This is dominant. Number three, subdivision rule. Number three, subdivision rule. Number three, subdivision rule. If the region of integration R, region of integration R is subdivided, if the region of integration R is subdivided into two, if the region of integration R is subdivided into two sub-regions, sub-rectangles, sub-rectangles R1 and R2, then you may write a rectangular region. If the rectangular region of integration R is subdivided into two sub-rectangles, R1 and R2, then fxy dy dE equal to R1 fx dE plus fxy. Just we shall apply these to solve these problems. For rectangular regions, A, B, C, D, you see, all are constants. All are constants here. If one is variable, then there is no problem. Then I will discuss, we will discuss it later on. When all the fxy is continuous and A, B, C, D are all constants, these are called rectangular region. And for rectangular regions, you may apply the Fubini's theorem. Any of the Fubini's theorem, then you will get the same result. Fubini's theorem applies only when A, B, C, D are constants. I told you earlier, A, B, C, D are constants. You will get the same way for rectangular region. Now let us try to solve number 1. What is this? Let us try to solve which one? Solve number 1. Double integration over R x square y to the power 5 dA. This can be written as x equal to 1 to 2 integrate y equal to 0 to 1 and x square y to the power 5 first integrate dy then dx. First integrate dy then dx. This is equal to x is equal to 1 to 2. While you are integrating this with respect to y, treat x as constant. X, if you take x as constant, it can be taken outside the sign of integration. And what is the integration of this y to the power 6 divided by 6? Now y is equal to 0 to 1 dx. You may write like this. This is equal to 1 by 6 can be taken outside the sign of integration. 1 to 2 x square 1 to the power 6 minus 0 to the power 6 dx. This is equal to 1 by 6 x is equal to 1 to 2 x square dx. This is equal to 1 by 6 x cubed by 3. It is nothing but x cubed by 3. This is equal to 1 by 6 into 3. 2 cube minus 1 cube. This is equal to 1 by 18. This is 8 minus 1 equal to 7 by 8. 7 by 18. Answer is 7 by 18. Now, y integration first. We have done it as y integration first. Therefore, you may write here A. Y integration first. Y integration first. First, we have integrated with respect to y. Then, with respect to x. We have found that the result is 7 by 18. Now, perhaps here is number B. Let me try to solve number B. X integration first. Double integration over R x square y to the power 5 dA. This is equal to y equal to 0 to 1 and x equal to 1 to 2 x square y to the power 5 dx. It will be dy. Yes, it will be dy. This is equal to y equal to 0 to 1. Now you are integrating with respect to x. Therefore, treat y as constant. Y to the power 5 x cubed by 3 x equal to 1 to 2. X is equal to 1 to 2. It is dy. This is equal to 1 by 3 integration y equal to 0 to 1 y to the power 5 2 cube minus 1 cube dy. 2 cube minus 1 cube minus 1. This is equal to 1 by 3 integration y equal to 0 to 1 y to the power 5 8 minus 1 dy equal to 7. This is equal to 7 by 3 integration y equal to 0 to 1 y to the power 5 dy. This is equal to 7 by 3. This is 7. This is 7. 7 by 3 y to the power 6 by 6 0 to 1. This is equal to, I am writing here, this is equal to 7 by 3 into 1 by 6. 1 to the power 6 minus 0 to the power 6 equal to 1. 7 by 18, 1 minus 0 equal to 7 by 18. In this way also we have obtained that the value of the double integration is 7 by 18. Thus we have done question number 1. We have done question number 1. It is 7 by 18. It is 7 by 18. Now come to question number 2. Let us try to solve the question number. What else we have understood? Let us try to solve the question number 2. Question number. What is this? Use an iterated integral to compute this, where R is the rectangle with vertices 0, 0, 3, 0, 3, 2, 0, 2. Suppose in a rectangle it is 0, 0 and it is 3, 0, it is 0, 2. And obviously it is 3. Obviously it is 3. It is the rectangular. This is the rectangle. Here the region of integration is. Here the region of integration. Region of integration is a rectangle such that x vary from x 0 to 3 and also y 0 to 2. Region of integration is this. Now try to solve this problem. Therefore, double integration over R 2 minus y dy dA equal to integration, suppose x is equal to 0 to 3, y equal to 0 to 2, 2 minus y dy then dx, dy then dx. Now integrate this. Take x as constant. There is no x. Therefore, you may write x is equal to 0 to 3, 0 to 3. X is equal to 0 to 3. Twice y minus y square by 2, y equal to 0 to 2 dx. Y equal to 0 to 2 dx. This is equal to this is equal to x equal to 0 to 3, 2 times of 2 minus 0 minus 1 by 2, 2 square minus 0 square dx, 2 square minus 0 square dx. Minus 0 square dx. This is equal to x equal to 0 to 3. It is 4 minus 1 by 2 into 4 dx equal to x equal to 0 to 3 4 minus 2 dx equal to x equal to 0 to 3 twice dx. This is equal to 2 times of x 0 to 3. This is equal to x is equal to 0 to 3. 3 minus 0 equal to 2 into 3 equal to 6. Answer is 6. The integration of this is 6. Alternatively, just you may integrate x integration first. Alternatively, by Fubini's theory, 2 minus y. This is continuous. This should be continuous. Number 1 and number 2. Y equal to 0 to 2. A, B, C, D are constants. 0 to 2. X equal to 0 to 3. It is 2 minus y dx. It is dy. 2 minus x. This is equal to y equal to 0 to 2. It is 2 minus yx. X equal to 0 to 3 dy. This is equal to y is equal to 0 to 2. 2 minus y. It is 3 minus 0 dy. You may write like this. This is equal to 3 times of 3 can be taken outside the sign of integration. Linearity rule, applying linearity rule. 3 can be taken outside. Y equal to 0 to 2 minus y dy. This is equal to 3 times of twice y minus, it is y square by 2. Y equal to 0 to 2. This is equal to 3 times of 2 into 2 minus 0 minus 1 by 2. 2 square minus 0 square. 2 square minus 0 square. 3. 4 minus 1 by 2 into 4. 4 minus 0 means 4. This is equal to 3 into 4 minus 2 equal to 3 into 2 equal to 6. Answer is 6. Answer is 6. The first answer is 7 by 18, I think, and the second answer is 6. Now let us try to solve the question number 3. It is very interesting. Why interesting? Why it is interesting? X is here. If you want to integrate x first, then you will have to integrate this by the rule of integration by parts. First function into integration of the second function minus the integration of the product of the differentiation of the first function and the integration of the second function. But if you integrate this with y integration first, then treat x as constant. When x is constant, then x cos of xy can be integrated easily with respect to y, treating x as constant. Now let us try to solve this question number 3. Let us try to solve this question number 3. Let us number 3. What is this? Double integration over R x cos of xy dA, and x limit 0 to pi by 2, y 0 to 1. This can be written as y equal to, suppose x equal to x constant on y equal to, 0 to 1, x equal to 0 to pi by 2, x cos xy dx dy. Now, if you integrate these, two functions are there. One is x and the other is cos of xy. Now you have to integrate this by integration by parts, treating y as constant. Or if you write it as like this, 0 to pi by 2, y equal to 0 to 1, x cos xy dy dx. Then treat x as constant. Simple function cos xy, cos of mx. What is the integration of cos of mx? It is cos mx divided by m. Here x is constant. This is equal to, treat x as constant, 0 to pi by 2. 0 to pi by 2. Treat x as constant, cos xy divided by x. Y equal to 0 to 1 dx. It is very easy. X will be cancelled here. Now here x will be cancelled. This is equal to x equal to 0 to pi by 2. Cos y equal to cos x minus cos 0. No, here it is. The integration of cos mx equal to sin mx divided by m. Sin mx divided by m. It is sin mx divided by m. Sin mx. Sin 0. dx. Cos mx, what is the integration of cos mx? Sin mx divided by m. Sin xy divided by x. Treat x as constant. Then you will get sin xy. Now put y equal to 1, then you will get sin x. Put y equal to 0, you will get sin 0. This is equal to sin x. X equal to 0 to pi by 2. Sin x dx, since sin 0 equal to 0. Since sin 0 equal to 0. Sin 0 equal to 0. What is the integration of sin x? Minus cos x. It is minus cos x. Minus cos x. X equal to 0 to pi by 2. This is equal to minus cos pi by 2. Plus cos 0. This is equal to minus 0 plus 1 equal to 1. The answer is 1. The answer of this question is 1. Answer 1. Answer 1. Now, if you first want to integrate this, then first function x, integrate this with respect to this, but integration by parts, then it will be more slightly complicated than this one. You should do that one which is more easier. If you integrate this, then it will be slightly complicated. And if you integrate this, it is absolutely easy, very easy. It is very easy. The answer is 1. Now, let us try to solve the question number 4. We have done up to question number 3. Let us try to solve the question number 4. Number 4. What is this? 0 to 1. 0 to x square. E to the power y by x dx dy. Dx dy. Now you see here. 0 to 1. It is constant. 0 to 1. This one constant, this one 0, and it is x square. If it is x square, then it must be y. Y varies from 0 to x square. Consequently, it will be x vary from 0 to 1. This is equal to x vary from 0 to 1 and y vary from 0 to x square dy dx. If one is not constant, this is not constant, then you have to integrate this first. You have to integrate this first. For it is obviously non-rectangular region. For non-rectangular region, which is variable, the limit is variable, 0 to x square. It is 0 to 1. It is constant limit. It will be integrated later on. First, integrate this one. Y equal to 0 to x square. What will be this? First, integrate e to the power y by x. It is of the form e to the power mx. What is the integration of e to the power mx? E to the power mx divided by m. E to the power mx divided by m. This is equal to x is equal to 0 to 1. E to the power y by x divided by 1 by x. Y equal to 0 to x square dx. This is equal to x equal to 0 to 1, x e to the power y by x, y equal to 0 to x square dx. This is equal to 8, x equal to 0 to 1, x e to the power x square by x minus e to the power 0 by x. This dx e to the power 0 by x dx. This is equal to x equal to 0 to 1 x e to the power x minus e to the power 0 dx. This is equal to x is equal to 0 to 1 x e to the power x minus 1 dx. This is equal to x is equal to 0 to 1 x e to the power x dx minus integration x dx. Look at this one. This is equal to first function integration of the second function, x is equal to 0 to 1 minus x equal to 0 to 1 differentiation of the first function, integration of the second function, whole thing into integral, minus x square by 2. It is 0 to 1. X square by 2, 0 to 1. Look at this one. This is equal to 1 into e to the power 1 minus 0 minus e to the power x 0 to 1 minus 1 by 2 1 square minus 0 square. This is equal to e minus, it will be e to the power 1 minus e to the power 0 minus 1 by 2 1 minus 0. 1 by 2 1 minus 0. What will be this? This is equal to e minus 1 minus 1 by 2 minus 1 by 2. This is equal to e minus e plus 1 minus 1 by 2. This is equal to 1 by 2. Answer is 1 by 2. Perhaps you have done no mistake. First function e minus 1, e minus 1, e minus 1, e minus 1. Yes, answer is half. The answer is half. Answer is half. Now, come to the last problem. Problem number 5. Come to the last problem. Problem number 5. Problem number 5. Let me remove this one. Problem number 5. This one is. Now here you see 0 to thrice y means x, it is y equal to 1 to 2, x equal to 0 to thrice y. Number 5. 1 to 2, 0 to thrice y, y dy dx equal to y equal to 1 to 2, x is equal to 0 to thrice y dx dy. You will have to write it like this. This is equal to y is equal to 1 to 2, it will be yx 0 thrice y dy. This is equal to y equal to 1 to 2, it is x equal to y thrice y minus 0 dy. This is equal to y is equal to 1 to 2 thrice y square dy. This is equal to y cube 1 to 2. With respect to x, yx. This is equal to 2 cube minus 1. 8 minus 1 is equal to 7. The answer is 7. Answer is 7. 1 to 2. Yes. Dear students, today I want to stop here. In the next class, we shall try to solve more problems on double integration. Today I want to stop here. Thank you. Thanks for attending the class. Thank you very much. Thank you.